Hey guys, in this video we're going to be doing 1B.4 and we should be able to prove if two expressions are equal by converting radical expressions to rational expressions. So looking at this, we're going to be dealing with a couple symbols here just to kind of go over it. Hopefully you know what they mean, right? Equal sign, hopefully you know what that looks like, right? It's our equal sign. And this right here simply means not equal. Right? So that's the two things we're going to be proving. Are our expressions equal or not equal? And the one thing that's going to help us out is to always, in these examples, we're going to change or convert. You could also think of it as convert. We're going to convert our radicals, right? So anything that has that little radical symbol to rational exponents. Alright, so what that means is anything that has a radical, that's the side you want to change. That's the side you're going to be converting to look like something that has a rational exponent. So looking at example 1 here, I have 7d raised to the 2/5 power. That's not a radical. That's already in rational form. So I'm not going to worry about changing that. He's just going to get brought down. That's what I'm trying to prove is equal on the other side. Now remember what I said about anything that has or that does not have parentheses that is in radical form. Remember that put that in parentheses and give it a power of 1 just so that you remember to keep that whole base together. So I'm going to keep that whole base together. And then I'm going to go ahead and write its rational exponent. So keep in mind again, exponent stays at the top. That little root number is at the bottom. And now I'm looking at these two expressions and I see, well, the bases are the same, right? 7d and 7d. And the denominators of the exponents are 5 and 5. But my numerators are not equal. So I'm going to just go ahead and put that not equal sign. And then to kind of keep that in mind, remember that they have different exponents, right? I have one that says 2/5 and the other one that says 1/5. Those are not equal. Alright, looking at the next example here, I'm going to go ahead and scroll over to example 2. Same thing, only changing the radicals to something that has a rational exponent. So again, the left side is going to change. I'm going to keep that as 5g raised to the 3/2. But the other side I am going to change it. Notice it's already in parentheses there, so I know my 5g is going to stay the same. It has an exponent there of a 3. And remember that common radical, we never really see that 2, it's invisible. So don't forget that that's a 2. So looking at these things, I have 5g raised to the 3/2 on the left, and that is the same thing I have on the right side. So those are equal. Maybe looking at some more challenging questions. Example 3. I have the 4th root of 81x squared, and I'm trying to see if that is equal to 3 times the square root of x. So I do have to change both sides because they are both radicals. So I'm going to go ahead and do that to the one on the left. I'm going to keep that base together, 81x squared raised to that 4th power. Oh, 1/4 power. Sorry, I forgot my imaginary power of 1. And then I'm going to go ahead and I'm going to distribute that to everything. Don't forget, I'm multiplying this to each exponent, which means my 81 also has that imaginary 1 exponent. So over here I'm going to have 81 1 times 1/4 x squared times 1/4, and then simplify. 81 to the 1/4 power x to the 1/2 power if I need to check this part in my calculator. Again, we know what that base is, so please go ahead and check that. Plug that in your calculator, raise that to the 1/4 power. The only time we don't need to do that is when we don't know what the base is, right? When you have a variable, it's kind of hard to figure out what you're raising to the 1/4 power. We get 3. So 81 to the 1/4 power is 3. This is going to be x to the 1/2. And now I'm going to go ahead and try to prove if the right side is equal to it. So I'm going to go bring that coefficient down to the 3, right? That's not going to change, it stays the same. My x, though, I have the square root of x, so keep in mind that root number is a 2, and it has that invisible power of a 1. So that's going to give me x to the 1/2 power. And that is the exact same thing that we have on the left side. So those are equal. Example number 4. We have to change, unfortunately, both sides because they are both in radical form. So keep in mind that cube root of 27x is still raised to that first power. I know that exponent's not there, but it is invisible, still there. So when I rewrite this, I'm going to have 27x raised to the 1/3 power. Don't forget that each of these have their own exponent of a 1. So when I distribute this 1/3, I have to distribute that to each of the exponents. So 27, 1 times 1/3 is just 1/3. X, 1 times 1/3 is just 1/3. I don't know this base, so I know my x to the 1/3 can be brought down, but I do know what this base is. So I'm going to go ahead and plug that into our calculator. So 27 raised to the 1/3 power is 3. So 3 x to the 1/3 I have on the left side. Looking at that right side, I'm going to bring that coefficient of a 9 down. Remember that my invisible exponent of a 1, my root is a 2. This is going to be x to the 1/2 power, which is not equal, right? The coefficients are different, the roots are different, so different roots and coefficients. Our last example in this video is going to be explaining why both sides of the equation are equivalent when written in exponential form. So focus on one side here. Remember, switching everything into radical form makes it a little bit easier to kind of see if things are equal. So looking at this first one, I'm going to go ahead and put that in parentheses and give it a power of 1 because it's not already in parentheses. So I'm going to have 64 x squared, all raised to the 1/6 power. I'm going to focus on the left side here. When I distribute this exponent in, I have to remember that this 64 has its own exponent of a 1. So that's going to bring me 64 to the 1/6 power. I'm going to have x squared. So x squared times 1/6. 64 x 2 times 1/6 is going to be 1/3. Oh, forgot my 1/6 here. 64 to the 1/6 x to the 1/3. I'm going to go ahead and substitute 64 to the 1/6 power in our calculator. So type in our base 64, raise that to the 1/6 power, which is 2. So I'm going to have 2x to the 1/3 power, which is on my left side. Now let's look at our right side here. This coefficient is going to get brought down. Keep in mind, this x doesn't have its exponent, so it's invisible, which gives me x to the 1/3 power. And if I look at both left and right side, those are equal, right? We knew they were already equal. We just need to try to prove it. So, explaining why, don't forget that part, right? It's in the directions. It says explain why. So, when switched into rational exponent form, right? That's what we did. We changed each radical into an exponent form. The coefficient, the base, the exponent, running out of room here, and roots are equal. Alright, so don't forget to give me at least something. The directions do say explain, don't lose those silly points, and forget to explain when you have all the correct words. So that brings us to the end of video 1B.4. You can go ahead and work on that activity. And then don't forget that after this section, there is also that AB quiz review. So once you get that 4B activity checked in, you can go ahead and work on that quiz review, and you will be taking that AB quiz. All right, good luck, guys.